it's about time to start learning again. Finished up figuring out all this stuff, except for this part I noticed when I was editing and going over the last video, actually. So let's just for a second, let's go over this and then go to the next step. So this is a Boolean move piece, char board size. So this is making the board size thing, the board thing that we saw, the array with the commas and whatever. And it also takes a parameter int start row, int start call, int end row, and int end call. So start row, start column, end row, end column. So now we're going to check if the move is within bounds. We've got start row, if start row is less than 0. So yeah, if start row is, why would it be that? But I don't know why, but if that's the case, it's going to be bad. If start row is greater than board size, so like 9, right? Same with column, same with the start column, and then same with the end column and the end row. So if any of that stuff happens, we're going to say we're going to do a console output move out of bounds. The move that's out of bounds. Let's just say out of bounds. I like that better. All right, and then end line. Return false because it's done. Check if there is a piece to move. Okay, so board start row, start call. If that's the case, if there's nothing there, like if it's just a space which indicates nothing, no piece at the starting position. There's no piece there. Try again. That's good enough. Check if the destination is empty. We can't move there. You can't move there. We can't. No, that's bad. Choose a different square. Choose a different location. Check if the move is diagonal. So if abs end row minus start row does not equal 1, or if the absolute value of end call minus start call is not 1. So it's got to be 1 if, okay, so we got to do like end row minus start row has to equal 1. So if end row is 3, the start row needs to be either 4 Yeah. It either needs to be 4 or 2. And same with this one. Whatever it is, it needs to be either 1 above or 1 below. It has to. It has to absolutely be that. Or it's not a move. Invalid move. Everybody knows that. It's checkers. If you don't know that, you'll figure it out soon enough. Perform the move. Board end row end call equals board start row start call. Okay. Yeah. This exists, and so now this exists with whatever piece this was, because this was either a red, either an R or a B, and this is now going to be a blank space. So if this was an R or a B, this is now an R or a B, and now this, yes, is a blank space. Perfect. So we know how this works. We might have to go over it again a few times because it's good to go over things more than once. All right, so there we go. So that's how that works. We already know how this works. We went over this in the last video. That was not yesterday when I made that. What are we doing now? Ah, yes. Let's figure it out. So let's go to ChatGPT. It's been a long time since we've made forward progress. Pardon me. We have this code. We have this code. And let's start. I'm going to bring this over to the other page and just drag it over. We have this code. What's it called? Piece.h. And I'll take this and I'll drop this. And I'll say semicolon space piece.cpp colon space. We'll come over here and I'll do Control A, Control C, over here, Control V. And that's not good enough. What the is that? That's not it, isn't it? Oh yeah. All right, cool. Keep it short. Boom. All right. Implement enhanced piece representation. Integrate the piece class into the board logic, replacing the character representation with piece objects for encapsulation and functionality. What? What? What is that? Oh man, hold on. Implement enhanced piece. Integrate the piece class into the board logic, replacing the character representation with piece objects for better encapsulation and functionality. Okay, I get it. So basically, put the piece graphics on the board. Hey, it's me in the middle of reviewing this thing, and editing it up and stuff like that. That being said, what I said about it, I don't even remember what I said, but the real thing is, after watching this, it's going to put a piece object. So we make the piece object in the piece constructor in the piece.h file, and instead of like the capital R and the capital B, like it was on the board, when we were doing the printout of it, it's going to actually have the piece, the red and the black pieces that we're going to have in this thing, that we're going to eventually have graphics for. You know what I'm saying? Just to let you know. Anyway, so let's get back to it. All right, add king functionality. Modify the move piece function to handle promotion to king and ensure kings can move backwards. All right, so change the king graphic and change the way it moves. All right, great. Oh, give me a second. All right, refine move validation. Improve the move validation logic to handle complex moves like capturing and multi-jumping, which are crucial for standard checkers games. Yes, so this is going to be the capture logic and the multi-jump logic. True. Introduce game states. Implement a system to track game states, ergo ongoing win, draw, which will help in determining the end of the game and identifying the winner. Yeah, so the win or loss, win, lose, draw right here. Enhance user interface. Yes, also important. Add clearer prompts and messages for user actions, and consider implementing a system to handle input errors more gracefully. So prompts, messages, more gracefully. Oh, okay. I don't know. We'll see about that. We're gonna do it as well as we can. Pardon me. Add an AI opponent. Yes, we're definitely gonna do that. Code refinement and documentation. Refactor code for clarity and efficiency. Yeah, we can do that. Add comments and documentation to make the code base maintainable and understandable. Sure. Testing and debugging. Create a suite of tests for crucial functionalities like move validation and game state transitions, and conduct thorough debugging sessions. We're going to do this. In fact, I'm going to save this. By following this outline, our project will have a solid foundation and improved user experience, making it more professional and enjoyable. I believe that that's a good thing. Anyway. So yeah, there we go. We got this. And so now what we're doing is this. Implement enhanced piece representation. Integrate the piece class onto the board logic. Okay. Okay, so let's do the piece stuff. Break that down into steps. Break that step down into steps. Step down into steps. Short answer. Make is short. But relative. Boom. Modify board initialization. Change the board array to store piece objects instead of characters. How do we do that? Update the initialize board function to place piece objects on the board where applicable. All right. So we're going to change the board array to store piece objects instead of characters. Huh? How do we do that? Oh, this. All right. How do we do that? I want to save this. All right, cool. So what we're going to do here is look at this. Change the board array to store piece objects instead of characters. Okay, how do we do this part? Break this part into steps and keep it short and sweet. Boom. Change the board's data type from a 2D character array to a 2D array of piece objects. How do I do that? Adjust the initialize board function to populate the board with new piece objects. So we just what? What? How do we do that? How do we do this? Do we just type piece? Well, that doesn't make sense. We do that. Modify the declaration in board.h, of course. Piece board size instead of char. Okay, so hold up. So you're saying piece is now a data type? Oh, that's crazy. That's crazy, man. That's how C++ works. So in the checkers game, piece is a class that we've defined which makes it a custom data type in C++. Okay. We can use it to create variables, or in this case, elements in an array, just like we would with built-in data types such as int, char, or double. That's cool. All right, so first we would change the board.h. What the? Why would we do? We wouldn't have to do that. We wouldn't have to do that. That doesn't make sense. But constant board size. We already got that. Piece board size, board size. Piece board size, board size. I know what to do. Watch this. Copy that. Is this what board.h should look like? Almost, but the board.h file should be slightly different to ensure that our board is properly defined to store piece objects, and that all the function prototypes are updated to work with a board of piece objects instead of char objects. And here's how we would define it. Okay. Include piece H. Okay. I don't understand this. Oh, it's board.h, of course. Okay, first we got to do that. Include piece.h. Schmooth. Do we gotta have a, oh, we gotta have a hashtag in front of that. And we gotta have this in quotes. Can I do shift over, control shift over, piece.h, no. no, piece.h. And then here we go. All right, that looks like it likes it. All right, cool. Include the piece class definition. I don't like that comment. Functions to handle the board. The piece class. Okay. For the piece class. Boom. All right, great. Let's look at this. Okay, so what? So I guess do we need to include the piece.h in board.ccp? All right. Do we need to include piece.h in board.cpp? Yes. Okay. Board.h. And then we'll do the same thing here. Copy that. Drop it down. Change board to piece.h. Awesome. All right, we got that. And now we've got initialized board. Blah, blah, blah. So let's change that up. All right, board row call is fine, but we're going to do piece R false. So this is going to be, we're going to make this the name. I imagine that's what this is. This has got to be the name of the red pieces. Okay. So we'll say piece and then after this we'll say false. What's the problem here? What's the problem here? Let's do the same for this one. Change it to B. Change it to B. Okay. Why doesn't it like this? What's up with that? Copy. Oh, we gotta do peace here? We gotta do peace on all of them, huh? Peace. And this will be peace also. Because when it's initialized, it's like that. Do we got to do something about piece.h? Probably. Okay. So yeah, we probably got to do something to piece.h. This ain't piece.h. Oh wait, is this piece.h? No. What do we do to piece.h? Yeah, oh, we still got that. We still got all that. So, okay, what's wrong with this? Okay, what's wrong with this? The main issue with what we did is that it still uses the char type. Ah, ha, 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 ha. Yeah, right? And that fixes everything. Perfect. Okay. So this will use our pieces. Okay. Great. That's good, but we can't really test it. Because watch, if we run it, see, something's wrong. Main.obj. Oh, we didn't change anything about this. I guess. Do we got to do something to the main dot? To the main.cpp? Yes, given the changes to the data structure of our board and the updated function signatures in our board.h and board.cpp files, we'll need to make corresponding updates in main.cpp to ensure everything works together smoothly. Here's a breakdown of what we need to do. So update board declaration. Change the declaration of the board in main.cpp to be a 2D array of piece objects rather than characters. Let's go to main. So this should be piece. Start with that. Maybe that was cool. Maybe not, actually. Maybe we'll figure it out. Okay. Change the declaration to be a 2D array of piece objects. What? Alright, let's see what they say. Adjust function calls. Update the calls. Initialize board. Display board. Move piece to pass the piece board array. Piece board array. Huh? What is, oh, what? Initialize board. Piece board. Oh, so what? We just changed it to piece, right? But what's wrong with these? Okay. Modify user input handling. Since our board setup now uses piece objects, we're going to ensure that the input handling for moves aligns with the zero-based index and that the logic in main.cpp matches the expectations of our updated move piece function. What? Since our board setup now uses piece objects, we're going to ensure that the input handling for moves aligns with the zero-based index and logic in main.cpp. What does that have to do with anything? That doesn't even... Oh, because of this. Maybe. Yeah, I guess. We already have that. So let's look down here and see what they're talking about. Board. Okay, so we did that. Initialize board. Why? Okay, it doesn't like that. While true, display board. Int. Okay. Enter the starting. Okay. Okay. Move piece. Okay. Why doesn't it like it? What is it? What's different? What's wrong with this? Line 7. Piece is not compatible with the type chart. Where do I have chart on here? I have to have it in piece.cpp. Yes. Piece.h. So piece.h, I didn't change that at all. Maybe it needs to be char. No. Piece type? No. What? Class peach piece. Oh, we private. We've got a private and a public. Oh. We gotta talk about this too. Private. We'll take this. Control X. Control V. Okay. Okay. Public. That thing that we made over here. The initializer as well. We got that right here. All right. Getter and setter for type. Char get type const. Oh my god. What? What is that? I'm so tired. This is so much. All right. Well, I don't know what any of this is, so we're just going to copy it and throw it in there. If it works, it works, and then we'll figure it out later. Okay. Save that. Let's go back to main. Still looking like crap, though. All right, this is the piece.h. Okay. Yeah, same. Anyway, why does it still not like it? Is it because of something down here? Here's main.cpp. All right. We're going to go file by file. What's wrong with this? Looks correct. Okay, so that's fine. If it's correct, just say so. Otherwise, what's wrong with this? I'm also going to take this, drop this right here, right there. We're going to use that as a prompt later. Let's actually adjust the size of this thing to include that down there. Awesome. All right, so here we go. So let's find out about this one. It's fine. All right, cool. I didn't do what I told it either. What is this? Why is this wrong? One overload. What? We're gonna see what this. Okay. Okay. Is this correct? Yes or no? All right, cool. Global array definitions. Declaring piece board side. Where is that? Right here. Directly in the header file can lead to multiple definition errors if the header is included in more than one source file. Instead, we should declare it as an extern in the header file and define it in the CPP file. What? Extern. Let's see if this works. Extern. Didn't clear that up. Save it. We'll see. So this is fine. So this is fine. Almost there. What is the difference? Oh shit, these need to be piece. This needs to be const piece. Why? Use const if function does not modify the board. Okay. Const piece. Piece. Well, it doesn't like this. It doesn't like this either. What's the problem here? Overload. Let's see. How's this? Yes, it's correct. Okay. But it still is acting bad. All right. How's this? Inconsistencies in our implementation regarding the type of the board and the display board and move piece functions. Since we've changed the board to use piece objects and initialize board, we need to update the display board and move piece, of course. Why didn't I think of that? All right. Okay, we're going to drag it with this thing. Move piece. Ah, yes, piece. Okay. Let's just take this and do the same right here. Piece board, piece board, piece board. Save it. Okay, something's wrong here. Let's see if this addresses it. Get type. Oh, we got to do something else. What's this get type? Where did we do that? This stuff. Okay. So we got to put get type in here. Check if there's a place to move and if the destination is empty. If blah get type equals this, or all right, if blah get type equals this, whoa, that's not it. What? Was this it? What? Are we on main? No, we're on board. Oh, yeah. Okay. It doesn't matter. Okay, it doesn't matter if this is painful. What matters is that it's working, sort of. All right, so here's this. Do we need to do anything different? No, this is fine. This needs to be changed. Check if there's a piece to move. So we got to do this one. Check if there's a piece to move. So if it is this or it is not. What? Oh, if it's this or if it's not. What? You know what I'm going to do? I'm going to copy this. I don't want to do that though. I want to understand it. I'm going to copy this and put it right here. Save it. Here's how's this look. Let's just take it and put it here and have it check its own code. Well structured. All right, cool. All right, how about this? Well structured. Where's the piece thing? Oh, it does piece board. All right, save that too. Does it run? Nope. Here's the errors. Board.h, board.h. Here's board.h. What? Do it again. No. All right, piece.cpp line 3. Here's piece.cpp. What's wrong with it? What? Say what? All right. Given our piece.cpp content, it seems that we are defining the piece constructor again in the CPP file. Are we? Are we? It doesn't look like it. In the CPP file? Oh, it was defined here and there. Oh, I see. I see. So what do we just... Yes. So what's P... So this is... So piece dot cpp is empty for now. Yes. Okay. What complex methods could there be? Let me read this to you. All right, in this setup, since all functionalities of the piece class are defined inline, including constructors, getters, and setters, there's no need for a piece.cpp. Okay, so we don't need this right now. Unless we plan to add more complex methods to the class that would be better suited for separate implementation in a CPP file. This helps keep our project simpler and may reduce compilation overhead slightly. Okay, but it's a matter of style and preference, especially for larger and more complex cases. What complex methods could there be? For a simple class like piece in a checkers game, the methods are typically straightforward. However, depending on how detailed and complex we want our game mechanics to be, we could expand the piece class to include more sophisticated behaviors. Here are a few examples of complex methods we might consider. Move validation method. Validate legal moves for each piece, considering if a piece is a king or not. Complexity. This involves checking the direction of the move, especially for non-king pieces, which can initially move only forward. And whether the move involves skipping over an opponent's piece for capturing. True. Capturing logic. Yeah, we got to do both of those things. Upgrade to king. We got to do that too. Serialization for saving loading game state. I don't know about that. Undo, redo. Okay. AI decision making. Okay. I like that, I guess. So yeah. Yeah, the capture and king for sure. And maybe the other stuff too. So do we set things up now? Do we set things up now, or just do it piece by piece? Methodically. Psh, what am I saying? I don't care. Methodically, of course. So implementing these features methodically and gradually can help manage complexity and ensure each part of our game functions correctly, before moving on to the next. So here's a suggested approach to structure our development process. That's the CPP. Wait, what? This the H, isn't it? Okay, what? Okay, what do we need to put that in? CPP or H? That looks like H. So just leave CPP empty for now. It's a piece of... Fine. Okay. Boom. No. Shut up. Boom. Let's see if it works. Okay. 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 I don't know why there are dots here now, but okay. Anyway, we got something working and it doesn't have a bug in it, so that's going to be the end of the video. That was 58 minutes. Jeez. This is the reality of it, guys. This is my reality, at least. Maybe you can do it like 1,000 million times better than me. It's possible. Honestly, it's really possible. I could be pretty dumb. I could be a dumb guy. The thing about it is, see, you have to understand. If you're dumb, the biggest thing you don't know is that you're dumb, right? And if I'm dumb, the biggest thing I don't know is if I'm dumb. And it doesn't really matter because we still got to keep going, no matter how dumb I am. Okay, that doesn't matter. It doesn't matter at all. What matters is we keep moving. All right, so we're gonna set. We already saved all this stuff. Let me make one of these bigger right there so I can edit it up better. Anyway, so yeah, on the next one we're gonna have to go through all over again, all this, all over again to make sure we understand. But hopefully it'll be a lot easier than last time. Anyway, so there's that, and we'll we'll see you next time.